Hey everyone, thank you so much for watching the Weaviate Podcast. I'm super excited to welcome Brian Raymond, the founder and CEO of Unstructured. Unstructured is such an exciting company for, I'll explain kind of the way that I see this space of kind of how do you get unstructured data like say PDFs or these corporate data lakes, web pages, all this stuff, kind of getting it into systems like Weaviate. And so I'm so excited to welcome Brian. Thank you so much for joining the podcast.
Thanks for having me. Excited to be here.
Awesome. So could you maybe kick it off? I know I might have given a course description, but can you explain what Unstructured is and the founding vision of it?
Yeah, absolutely. So when we embarked on this kind of journey that we're on today with Unstructured, the vision was pre-processing is terrible. Nobody likes it. It takes forever, but it's a critical step if you actually want to deploy language models of any type against data that's important to you. And so I had the last 4 years before I started Unstructured, I was with a great company called Primer AI. And at Primer, we were fine-tuning models, orchestrating pipelines, building applications on top of them, doing all sorts of really cool stuff with transformer-based models. And we'd have these fantastic applications, and we'd show them to customers and say, "I want that on my data." And then we'd look at their data and we'd hold their head in our hands and be like, this is going to be a huge amount of work and regexes and Python scripts and OCR and everything just to get everything into typically like a nice clean JSON format, right? So that we can feed it into an inference pipeline. And so the vision when we started out was, hey, Hugging Face is exploding over here with tens of thousands of models, incredible community. What if we did something similar to the left of Hugging Face and we made it cheap, fast, and easy for data scientists to get through that data engineering step so they can consume more of that? And so, initially it was, hey, let's help folks build out these bespoke pre-processing pipelines to take, say, a non-disclosure agreement that's in a PDF. You want to train a classifier model or something on it. How do you get that into JSON? Or I got a bunch of PowerPoints or CRM data or scraped HTML. How do you get that to a point where you can start interacting with it? And so for the past 10 months or so, we've just been in build mode, focused like a laser on ingestion and pre-processing. A little bit of work on connectors, but mainly on that transformation, that file transformation work to get it into a base format that you can go use with machine learning.
Absolutely fascinating. Really, captivating overview of the thing. To kind of maybe to break that in. So pre-processing, is this like, are you thinking about like I know obviously there's like the PDFs to Weaviate kind of angle that we're so excited about learning more about, but I think also you're hitting on like kind of like the ETL, like when you are a data scientist and you take like a CSV and you look for like missing values, the range of the distribution of your features. Is this the kind of thing that you think about, like that kind of pre-processing? Can you tell me more about the pre-processing?
Yeah, and it's its own weird space here on pre-processing with files that contain natural language data. And so we think about it in internally in terms of like 3 steps. Okay, the first thing you want to do is you want to partition and extract the natural language data from a particular file, right? And so if it's, a JPEG that's of a billboard, or if it's a Word document or a text file or whatever, you still want to detect, you want to detect like, okay, this is a headline, this is body text, this is an image caption, because you want to be thoughtful about down the stream about what you put into your inference pipeline. You want to extract that data, and that's a whole process in and of itself of doing that. And so, Matt, so once you've done that, once you've partitioned and extracted that data, the next step in our world is cleaning. And how do you reduce it down to like a clean markdown file or JSON? So there's all sorts of artifacts that wind their way in here. So like sentence fragments and weird white spaces and Unicode characters and all sorts of just like little gremlins that just burn up time on cleaning that up. And so we have spent a lot of time thinking about that cleaning step. And so once you have that clean step, as a data scientist, your job's you're not ready yet. You got to stage it. And there's a lot of work that is in the staging still, which is last mile that burns up time. So concatenization, chunking, tokenization, creating embeddings, mapping JSON schemas for maybe you want to set up a labeling task. Maybe you want to dump it in a vector DB. Maybe you want to send it to a Hugging Face pipeline, whatever that might be. There's a lot of that last mile kind of staging work that has to be done. So partition, clean, stage, and then you're ready for ML. And all of that today is still completely manual. And that's why 80% of data scientists' work in this domain is actually on this pre-processing stuff that they don't want to be doing. They want to be doing the modeling. And so we're trying to give that time back to them.
Yeah, amazing. Data scientists always saying like, "Oh, the data cleaning, the most painful part, but the most productive part." And so yeah, the pain point is so clear, and the problem being solved, so useful. So I think kind of I want to take into this question of the why now question, sort of like the how large language models are facilitating unstructured in this technology. What's now making it easier?
I think what large language models have done is really increase the demand side of the equation, the right hand side of the
Mm.
equation, where there's a couple attributes of them that are really important. One of them is that from a generation, and I'm not telling anyone anything they don't already know, but like they're just a lot easier to use for generative tasks, right? Than old, kind of the older class of models, and so it's just the time to value and the cost to value is a lot lower. And the second is that they're a lot less fragile, a lot less brittle to the data that you're putting in them and to the
Mm.
prompt if you're using like in context learning or whatever. And so what that means for us is that our persona has shifted a little bit. So we were in a world where you needed to create these incredibly accurate pre-processing pipelines because if there's any noise or shift in the document template or anything, it would throw off a lot of the downstream, the structured data that may be fed into a knowledge graph or something downstream.
Mm.
Now, since they're a bit more tolerant and there's a lot more that you can do with them, folks are saying, "Hey, I want to use everything that we're producing, like every file type, everywhere we're recreating, natural language data that's relevant to our organization. I want to use it in conjunction with a language model, right?" And so on our end, it's gone from lots of super precise pre-processing pipelines to, hey, how do I take an S3 bucket or an Azure blob full of just everything that you can imagine, send it through unstructured, and then dump it in Weaviate, and now I can chat my data or interact with it that way, right? And so that's shifted some of our the paradigm that we're approaching a lot of our engineering work and what we're prioritizing.
Got you, got you. Let me get your thoughts on that. I remember like with LangChain and Llama Index when they came out, they had like a data connectors hub, and I remember things like S3, Google Drive, Notion, like or just like the PDFs. So, what was your reaction to that kind of thing? Is that kind of the like a lot of the unstructured part is like connecting to these data sources as well as the transformations?
Oh yeah, I mean Jerry and Harrison have done just awesome work there, and unlocking a lot of this the potential over here. We're looking to kind of build on their shoulders for enterprise production grade deployments. And it's just a slightly different sort of take on it that's feeding into our engineering requirements. And so what that means in practical terms is that like we're I'll talk about our connectors and how we're thinking about connectors versus data loaders, right? And the
Mm.
complementarity there. And then also what we're doing on the transform side that's not there. And really this is a story about how do you enable all the data, like the thousands of data scientists out there right now that are prototyping, for them to go from prototype to production. And I know Harrison's been spending a ton of time talking about productionization of agents and these other things. We're in this narrow strike. We're staying disciplined in this narrow strike zone of ingestion and pre-processing. So on the connector side, some things that differentiate our abstractions from those data loaders are that the data loaders are kind of grabbing everything and moving them over.
Mm.
We're able to ascribe canonical numbers to them, and so we can measure net new, and so not grab everything, and so you're not shifting a lot of duplicate data in. And then also thinking about scheduling, and these will be supported by us. So if they break in the middle of
Mm.
the night, unstructured will fix. Kind of like a Fivetran type approach, but they're built for the ground up, from the ground up with LLMs in mind. And so some other things like we're building them in such a way that they lend themselves to parallelization across like CPUs. Um, and so that's like a whole discussion in and of itself on the connector side. But once you connect and you grab that data and that net new data from G Drive or SharePoint or Azure Blob or whatever, we're doing all that transform work, that the partition clean stage, right, and then handing off. Like our goal is for our users to be able to take raw data, grab it, transform it, and then hand off wherever it might go. It might be a vector database like Weaviate, without having to worry about any additional data engineering. It's ready to go. And so we've gone from raw to ML ready with an unstructured.
And so I think that there's a huge innovation in. I wanted to talk about this kind of like PDFs to Weaviate. I think this is one of the most exciting topics. Is that we've seen this at hackathons and stuff as people they want to chat with their PDFs because it makes a lot of sense. So could we talk about the innovations in unstructured? Like how would you process a PDF with unstructured?
Yeah, we're doing a ton of internal R&D work right now in this area that spans a few different approaches, and what we're imagining in our for our kind of target persona are folks that are like our organizations that are producing huge volumes of data a day. So we're thinking a lot about compute efficiency. Like some of the large organizations that we're working with today create and process more than like 250,000 files a day. And so you don't want to burn up all your compute budget on pre-processing, right? And LLMs are, even though you can use LLMs for some of these things, they're about 100 times more expensive than the approaches that we're taking. And so we're like, okay, how do you render the highest quality data with the least amount of compute so that you can get to a chat your data type approach? And so one of them, we're taking like Yellow X, and we're fine tuning that on our internal label data. We got like tens of thousands of pieces of label data that we've been curating over the last several months, and so that's Yellow X is creating the bounding boxes. Choose your OCR vendor of choice, abstract, whatever, and then couple it with our staging bricks. And now, voila, you're ready to rock and roll. That's one approach. Another approach is like a donut-based approach. So OCRless vision vision transformer, where we've been doing a lot of work there. Some performance, benefits and trade-offs between that and an OCR approach, and then also implications for compute. And so that's like another one. You'll be seeing those APIs coming out soon. Our general pipeline, which is relies more on like more traditional CV and NLP approaches, and that's available today. And then we're also pre-training our own foundation model from the ground up. That's our own vision transformer, where we've curated all the pre-training data and we've curated all the fine-tuning data, and with the idea being, hey, let's train a model that you can throw almost anything at it, and it's seen it, and it can transform it and render it with a high degree of performance. That's in process too. We're just wrapping up pre-training and transitioning to fine-tuning on that. And so the goal is by midsummer to have a wide range of different kind of like arrows in our quiver that our users can use to get over that hump and to get to that clean JSON.
Amazing. A couple of things I want to take apart. Firstly, I think just your knowledge of the state of the art in OCR and I think Swin transformers. Could you maybe just kind of explain that more? Because I know I don't know that much about it. I'm sure our listeners are curious about it.
Sure. I mean, at a high level here, a lot of the approaches to date have been, infer bounding boxes around document elements. And there's some models that work pretty well on that. We've been doing a lot of really focused work on folks, stuff that'll just put a lot of people to bed, to sleep. But how do you accurately draw a bounding box around an image caption and differentiate that from a list, from a header or a footer or any of these things, so that you have accurate metadata tags, so you can strip all that stuff out and focus like a laser on exactly what you want downstream, so you can curate your data. And so that's vision, a computer vision model coupled with OCR to do the extraction, and then you can do some last mile tuning before you roll. On the vision transformer based approach, it's really interesting. So it's tiling up a particular image, and it's using an OCR-less approach so it's a vision encoder and then a text decoder in order to do the jump from an image in to JSON out. And we're pretty optimistic about that approach, both from a compute standpoint and a performance. But depending on the needs of the user, if the user is going to need like coordinates for traceability, like where a particular extraction came from and which page and where on a document, all those specifics may necessitate a different approach. And so our goal is to have like a nice wide menu of approaches that kind of balance features with compute efficiency.
It's so interesting to learn about all this. I mean, I want to come back into the plans of the foundation model. I'm very curious, like how you're seeing training a custom foundation model and exactly what that'll look like for unstructured. But I'm curious about like with the so with visual document layout, and then I feel like web scraping is a huge application of this. Where I'm like,
Yeah.
we also just recorded a podcast with the Kappa guys who took all the documentation blog posts of Weaviate and put it into one of these retrieval augmented systems, and I mean it's really remarkable. And so like, could you just point me to a web, like if I just had Weaviate.io, just this website, how would you then go about getting all the data out of it?
So what we're doing is instead of trying to parse the HTML like really effectively, and because it can be like there's some solutions for it that work pretty well, but they're not like fantastic. So what we're doing is instead we're reassembling the web pages and then imaging those pages and then feeding those essentially like screenshots of the
Yeah.
web pages through the model, right, in order to do that. And we think that approach, and there's been some recent like really great Twitter threads and some papers on this, that the compute efficiency of these computer vision models is coming down, and so you can do that at scale, and the performance of those extractions is going to be a lot better than what you can do in just the pure HTML parsing.
Yeah, that is incredibly exciting. I mean, I think, yeah, wow, it's really like you're really painting a compelling vision for the future of multimodal. I think about just like, I like to read a lot of scientific papers, and I think about how much information is captured visually in the diagrams. But then the next question, and this is something that I've heard so many times with the vector search, is like, so with tables, you can also kind of like extract tables and charts and stuff. Yeah. I mean, I don't know if the question is maybe pretty self obvious. I think you do the same kind of thing as the OCR models and all that. So yeah, so I think it would be a good transition to come back to that foundation model. So training your own foundation model to do this kind of, I want to say, document layout parsing. Is that kind of the idea?
Yeah, raw to JSON for files that contain natural language, and so feed in anything, almost any file. And what the approach that we're taking is convert it to, with this particular model, we'll have other options, but with this particular model, convert everything to an image, vision encoder, text decoder, and you get JSON out. And it has, instead of just one big brick of text, which is kind of like what you have with the document loaders now,
Right.
what we're doing is we're taking snippets out and saying, okay, this is the title, and having a title metadata tag, and this is a body text, body text chunk, so on and so forth. And so you can be much more thoughtful about, one, what you're wanting to store, and then two, what you're feeding into prompts, right, downstream. And so again, everything at the end of the day is going to come down to speed and cost of compute. And you can chew up a lot if you're doing this in production for an enterprise, without having done that work on the front end. And so the goal then with this larger model then is take huge volumes of heterogeneous data, and then you can curate it very thoughtfully before you decide to go spend a bunch of money on all of it within the LLM. And like Jerry over at Luminex, he had a great piece in Medium just last week looking at Claude and 100,000 token window. It's $1 a prompt almost. Every every time you query the model. I mean, if you're doing this across an organization, right, like that's going to add up in a hurry. And so what could you do to maybe avoid having it look across 100,000 tokens, even if you can, do you want to? Right.
Yeah, and that brings me to one of the topics I'm the most excited to talk to you about, which is this kind of like extracting structured data from unstructured data. And to as a quick background, like with Weaviate vector search, in addition to doing vector search or hybrid search, we also have where filters. So if you want to say like, where web page equals Weaviate IO, or like where price equals less than, or like price is less than $100, like these kind of symbolic filters, they integrate with the HNSW vector index to facilitate using this kind of structured data in addition to searching through the text chunks or bricks. I think that I like that abstraction a lot. Think about it as bricks. But so I wanted to get your thoughts on this one paper, and I'll give a TLDR quickly, just in case, for everyone out there. So this paper is called Evaporate-Code Plus is the name of the algorithm. And so what you do is, say you're looking at Wikipedia pages of NBA players. First, you look at a subset, so like Kevin Durant, Jason Tatum, LeBron James, and so from you look at this whole thing with an expensive large language model, take out the symbolic attributes like college, height, years in the NBA, let's say, and then the large language model writes Python programs to extract those attributes, and then you generalize the Python programs to doing the rest of the Wikipedia pages. So hopefully that was a good explanation of the technique. And if it's not unclear, I'd be happy to clarify. But do you think about that kind of like bootstrapped, like here are the attributes, and then here's a way to extract the attributes from unstructured data?
Yeah, I think once you get it into that clean JSON that's prepped and ready to go, like we think there's a lot of complexity in connecting to everywhere that an enterprise or an organization stores a lot of this data, and then
Mhm.
all of the long tail of file formats. And so we've been less focused to date on trying to adapt like GPT-4 or a Bard or something like that in order to do all of that, because
Mm.
over time we may pivot if the compute efficiency improves and like the performance improves of that, to say, okay, let's build an ingestion and pre-processing platform from the ground up to do that, get it into that base format, and then use LLMs on top of that,
Mm.
on top of that data. It's just going to be a lot faster and a lot cheaper, and it's going to be more performant for the most part right now. And I think you're seeing some of these challenges with like agents right now and moving them into production, like incredibly promising, incredibly exciting. Nobody's using them in production really yet, right? And it's going to be a while. And so, like, we welcome open source community continuing to to work on that, and like as they progress, like we may pivot on our strategy, but we're most bullish on putting the LLMs against the clean JSON, and then asking, because you're just asking a lot less of the model, which means that the structured data that comes out the other end is going to be a lot higher quality.
Gotcha. I think I'm starting to understand a bit. So say I have like like Parquet files or CSV files, or maybe I have like a graph database, like I have some data in Neo4j, and I come to Unstructured and I say, hey, could you transform this into, like, I need a Weaviate database. Could you turn this into, could you like read the documentation and learn about however you transform data from one file to another? Is that kind of the general thinking? And so could you shed more light on what exactly that looks like? Because I'm sure you have a lot more knowledge about that thing.
Yeah, on our side, we've done a lot of work on staging bricks on like JSON or Markdown transformations. And so once we get it into a particular base format, or CSV, adapting it to what's needed. And this is really like last year we were doing a lot of work around like Label Studio and Snorkel and Labelbox and like the long tail of labeling, vendors, and then also some of the NLP vendors. And everyone had like a slightly different JSON schema requirement. And so we were doing a lot of work on these staging bricks, which would take a base one and then adapt it to the schema that's required for that particular downstream application. And we're probably going to need to continue doing more of this. But again, like our kind of our strike zone is, okay, I have a file that contains natural language, and I need to get that into a consistent format so where I can curate it for to create a knowledge graph or something like that, right? And so
Mhm.
um, that's really kind of the sand trap for data scientists today, and where I don't think we claim that we've solved it by any means, but we're running hard against that particular problem set.
It really, I mean, I think like, so if I could understand the problem a little better, so I know things like, say I have some kind of special character in my unstructured text that when I try to decode it, it's like, ASCII can't decode this character. So I'm mostly thinking about problems like that, like where
Yeah, and those are bound, and so we have all those cleaning bricks around those types of problems, right? That are just focused on that we're trying to actually embed those cleaning bricks into these models, and so these models are doing the partitioning, the extraction, the cleaning, all in one
Hmm.
step, and then you can stage it however you can make those choices that you want with our our staging bricks downstream. But that's where, like, data scientists that are dealing with this natural language data that are needing high quality pre-processing, that's where they're getting bogged down today on just writing custom Python, custom regexes, and kludging it all
Hmm.
together. And then if you change the document template a little bit, everything breaks and they got to start over again, right? And so um, it's that sort of that step right there that we think we're probably delivering the most value.
So is it correct? Like I'm thinking about maybe like with how with like say like no SQL systems you have like this evolving schema. You can transform your schema as your data kind of evolves and you're adding new properties, attributes, and then it's kind of like the syncing up of that at massive scale. It could be one other part of it.
What we've done is we've come up with our own ontology, just mainly because the one that doesn't exist yet, of document elements. So instead of like
Mm.
of columns and rows, it's like, okay, like we we did a lot of thinking this, like, over the winter and the spring. We're like, okay, like we need a bunch of categories, but we don't need too many categories of like, what are common across receipts and PowerPoints and memos and web, right? And like
Yeah.
in the natural language domain, where, like, some of them I mentioned already, but like lists and headers and footers and advertisement and captions and
Uh,
all of these things. And so what you end up with are token spans with a metadata tag to what type of like universal document element that corresponds to. And so you could say, oh, I want to like exclude all of the headers and footers and captions from what I send to Weaviate, because I don't want those getting sucked up into what I'm prompting against, for example, right, with an LLM. Or I want everything, or I just want to isolate some things. And so that allows like this rapid curation rather than having to guess and check, writing regexes and Python scripts and then changes and then it's miscategorizing it. You can do that effortlessly with our toolkit.
Awesome. Yeah, that quick list of the PowerPoints receipts that helped it click for me a little more. Just like wow, like how much information is visually organized. I have to yeah, like I'm so biased in my own like experience of thinking just about like, archive papers and like blog posts is the thing, but I mean, can you tell me more about just like what you're seeing with all the information out there that's like a visual document layout? Like I don't know. I mean, PowerPoints, receipts are it's pretty
Yeah,
exhaustive.
I mean, the world that we like, the customers we're talking to are primarily large organizations, and just think about, like, okay, how many data loaders have all the developers that are supporting Llama Index
Mm.
and LangChain and others come up with, right? And a lot of those are kind of like easier data set. And then you have Salesforce and you have HubSpot. On the other hand, you have Slack and you have Notion, and then you have stuff that's out there on the internet, and then you have who knows what in G Drive or in SharePoint, and then you have historical things that are
Mm.
stored in an S3 bucket, right? That nobody's ever done anything with. You have recordings of podcasts and things like that,
Yeah.
right? That you can run through speech to text. But the bottom line, all of this, like, there's this whole world of private information that organizations are generating every day that's specific to their particular mission, right?
Yeah.
And the exciting thing here is, like, how do we, like, for them, it's how do we take what's out there and publicly available, what we're generating internally,
Mm.
somewhere like Weaviate, and then utilize it in conjunction with an LLM either to enhance productivity or to make better decisions. And maybe we write memos a particular way. Maybe we make presentations a certain way. Maybe there's this historical knowledge about how we do things, and I can query. I have this vision of being able to query it. How do we take all that valuable natural language data that's everywhere, and then get it into Weaviate, for example, right? And utilize it in conjunction with LLM. Like, that's what's so exciting for these organizations right now. But there's some huge bottlenecks along that journey for them to navigate.
Amazing. I mean, I think about like how, like within our company, how information is kind of like visually organized and like Notion and Confluence, and maybe like even like a Jira board, you could visually look at it and then parse it out from that. And even just like as I was did that, let's list out some things. I started thinking about like resumes that are visually organized and parsing that out. Yeah, it's all just incredibly interesting. So let me ask you about this kind of chunking and determining atomic units for text. So we generally, with text embedding models, try to get it to around like 512 tokens. And so like with, LangChain has this recursive character splitter thing as a part of their PDF ingestion, or like as part of their data ingestion library, where basically what it does is, it like, if you have like, it has a few elements to it. So firstly, like if you have 1,500 tokens, it'll like chunk it up, the first 512, next 512, and then the remaining thing, send that all out to the vector database or whatever. Or it'll be like if you're trying to parse like a Python file, it'll like particularly have delimiters for like new lines or like def for the function, like these kind of little things. So do you think there's a lot of innovation in chunking?
Yeah, and I think like what we're, at least for on our end, I think Harrison's on the right track with the recursive text splitter. I think where we're going with that is chunking into increasingly smaller units that have the metadata tags associated with it. And so you're not like, let's use a web page, for example. Let's say you scrape a New York Times, a long New York Times article, right? And what'll happen right now is like that'll get chunked into 512 token spans or something like that, right? But within that, you'll have advertisements, you'll have links to other articles, you'll have image captions, you'll have all sorts of stuff, right? Maybe a text box about the author or about a related
Mm-hmm.
article, and all of that.
Mm-hmm.
In an ideal world, like if you're just doing chat your data, it probably doesn't matter as much. If you're wanting to continuously update knowledge graphs or like Salesforce or something like that, using LLMs matters a lot more. And so what you want, right, is to say, okay, here's this chunk of like maybe body text that's split up by 512 tokens, right? But then I know that this is an advertisement, and I know this is a text box that's talking about something else, and I know that these other elements aren't necessarily related to the topic of this article right here that corresponds to this headline. And so you can just do a little bit of work on the front end, like through Unstructured, so that you're not asking nearly as much of the LLM, and that when you're ready to turn the corner from chat your data to continuously update knowledge graphs or automate processes,
Mm-hmm.
there's going to be a lot less noise going into that data itself.
Yeah, it's super interesting, and I do want to like. So you mentioned knowledge graphs, and this is probably like the most use of structure is to connect each chunk to how it's like related to another chunk and this kind of thing. Well, earlier I had mentioned this kind of idea of just adding symbolic filters to your chunks and then using Weaviate to search through these symbolic filters, and then like it reminds me of say like the text to SQL kind of research where you could have an LLM generate a query that adds symbolic structure to the semantic search query. But broadly, what I want to ask you about is what is your sentiment on knowledge graphs? Do you think knowledge graphs are, like if you're betting on knowledge graphs as being more or less important as, in the next 3 to 5 years?
I think like what we've seen in the last 6 months has been the fact that like chat your data has captured everyone's attention. And I think
Mm-hmm.
that that's going to continue, and it's incredibly exciting. What I also think is that for a lot of business processes and organization processes, um, you need a high degree of precision in order to hand things off to automation. And that is in the realm of knowledge graphs. And so if it's classification to like, or topic modeling on the one hand, to entity extraction, to relation extraction among entities, and then more, right? Those are still like there's still a ton of manual human work being done in those areas that like the previous generation transform based models were good at, but really expensive to set up and really brittle. And that like you didn't see widespread adoption of NLP across like Fortune 50, Fortune 500 organizations, in large part because there's a huge economic problem around it. The economics are changing in a really positive direction, but it's still not a solved problem. And so I think like we have a renewed opportunity as an NLP community to go and attack that and to drive that value. But that value has not been delivered yet, by and large, right? It's been prototyped and it's been described, and there's been lots of cool Twitter demos, but like there's still thousands and thousands of humans doing things that models can do well. And so now we have a chance to go back and reattack that. And so I think you're gonna like there's just the generative tasks and others where chat your data or prompt your data is better, but there's still a lot that like structure like the creation and maintenance of knowledge graphs are necessary if you're going to hand it off from humans to models.
I think yeah. So with the knowledge graphs, I'm just really curious, like if we could unpack a little more of when you need to use a knowledge graph. I don't mean to be like, because I'm just kind of skeptical. Honestly, I'm like, to me, I think the best thing about a knowledge graph is that if we link together the how chunks are related to each other, maybe we can use some kind of graph neural network to kind of have embeddings flow through the graph and maybe get a more contextual sense of the embeddings. That's more so how I like a knowledge graph. Can you tell me just like about when you query, like, because you have the relational tuples like Connor, and then all the things about me, just as an example. Can you tell me more about like how you query knowledge graphs and how that's useful in business?
Yeah, I think look, there's events and there's entities, right? And the entities can be organizations, they can be SKUs, they can be like supplier relationships. There's all sorts of things, right? And then there's all sorts of structured data associated with that relationship to meaning like what are key events that happened, what are key transactions,
Mm.
um, lots of things that are described in natural language that aren't that might not necessarily be in a structured format already, that you need to go attach to that record, right? If you're actually going to hand things off. And so let me give you an example. We were talking with an investment advisory firm several months back, and they advise like endowments and others on investment, and they themselves are receiving every month hundreds of limited part LP reports, uh, McKinsey reports, like consulting reports, like all sorts of data. Some kind of in a gray area if it's private or not. Some really private, and they have a whole team of people that are just reading them and then just updating them into a CRM so that they have like 100% accurate information on any particular business entity at any given time to inform
Mm.
investment decisions. Yes, you can put an LLM on top of that and ask questions, but were you going to trust it with $100 million decision? Probably not. Probably not, right? And so if you're going to feed in all of those PowerPoint decks, the McKinsey reports, those LP memos, all that sort of stuff, and you want to create 100% accurate or 99.999% accurate records about certain securities organizations, um, you're going to want like very high quality knowledge graph associated with it, even though you could chat your data. And so
Gotcha.
how the LLMs demonstrate that level of performance of the previous generation of transformer based models, like it's going to be a challenge, right? And so there's that's probably the more common NLP use case today than Goldman Sachs wanting to chat all of their data across all of their divisions.
Yeah, amazing. I mean, that example really like lit a fire under my ass of the thinking about Goldman Sachs, and I now like the hallucination thing of you give it the thing and it hallucinates. So, how are you thinking? I mean, that's a great example of a hallucination case where you just absolutely cannot hallucinate. Maybe we could talk about this topic quickly about the innovations and hallucinations. Like, it seems like there are some things you like as the language models get better and better, it's becoming less of a problem that maybe I could just I guess it's kind of two things. Like with the knowledge graph thing, it's like do I need these tuple? Like it's entity, relation, entity. This is how I should have my data structured in order to hand it to the Goldman Sachs LLM, or can I just have it kind of be like a natural sentence that comes out of a retrieval engine to hand to the large language model?
Yeah, I think, I mean, you deal with a lot of like type 1 and type 2 problems here of like, hey, did I is what's being generated anchored on something real, or on something, that bears a significant resemblance, or the other thing is like, um, is it missing something in the generative side, right? Is there an unknown, right? And so like both of those are critical to actually like putting this into production.
Hmm.
And so I think like by and large hallucination is a lot less of a problem than we thought it was maybe 6 months ago,
Mhm.
from like an open source developer community perspective. From a production perspective, this is an area ripe for innovation, because we might be able to make sure that like what is generated is anchored on something real. But I haven't seen a whole lot yet around making sure that you have a totality of information, of the right information being rendered for you. And like, look, you can look at like like Google's LLM versus OpenAI's LLM and some of the horse racing just in the past few days between them on what they're returning from prompts, from very similar prompts. And it's still early days, right? And so that's not to say that these aren't incredible, but like, there's, I think there's still a chasm between pure like Jasper AI generative applications and replacing humans that are doing knowledge generation work, right?
Hmm.
Today.
Yeah, amazing. And yeah, so I think that was a really great coverage of all these topics. I think what you've hit on with the particularly kind of the visual document layout is what originally drew me to Unstructured. And I think you have hit such an important part of this kind of flow of these retrieval augmented LLM vector database all the world that we're in. And yeah, it was so interesting learning about how you think about all these things like the data connector, like, flowing data from say like Parquet into the JSON as you describe all that is so interesting. Before we wrap up, maybe do you have any like exciting upcoming announcements or any tips and viewers for where to catch up with you?
Yeah, I'd say, we're in our community Slack. Welcome others to hop on in. We have our engineers are in there full time answering questions. The ones who are building are answering questions directly, and so we have an amazing team. Stay tuned for some new models to be dropping over the next eight weeks. We're going to have a good steady drip of those, and just welcome feedback. We're trying to build through real problems through real users, and leverage the power of this open source community. And so grateful for any contributions or feedback anyone provides. But Connor, thanks for having me on.
Thank you so much for your time, Brian. And yeah, not to keep rolling out on the Ezra, but as I did my list, that new when you mentioned the suite of the new extraction models, we are definitely going to be on top of that at Weaviate, trying to help people get their data into Weaviate using these tools from Unstructured. And yeah, thanks again.
Thanks.